Grade 9s, how are we doing today? Or should I say, Qlickers? How are you? I hope you guys are having a good time. Here today, I'm here to explain to you how to do straight line graphs, but not so much on the dual intercept method. That's something we've covered previously in the IGTV videos, alright? And then how do we construct the straight line graph? We've also done that before. But today I want to start off with showing you something like this. Here we have two straight lines intersecting one another, right? This is like the next step up, right? But I'm here today to explain all these sort of intricate and complicated details to make sure that you are able to do a question like this. So when two graphs intersect one another, given our equations, right? We have been given our equations, which is perfect. However, I noticed that this equation over here is y is equal to x minus 2, which is the format that we normally and always see it in. Because what is the format of a straight line graph? It is y is equal to mx plus c, where m is my gradient, m is the gradient. Feel free to take down notes of this stuff, right? Take a screenshot, and c is my y-intercept. So, because this is in its pure form of y, in its singular form, alright, there's no coefficient of y, which is very, very important. Otherwise, we'd have to simplify it. So y is equal to x minus 2. The coefficient of my x term is my gradient. So what is the coefficient of this x? It's 1. So the gradient of this graph would be 1. The constant at the end, the constant, the c, represents my y-intercept. So that means that I know that this graph, alright, is cutting at negative 2. That's where the y-intercept is. Negative 2 over here. So I know that this point here will be negative 2. And that's just through looking at it, through observation. But the issue comes into play when I look at the equation of Q. What is happening here? I've got 2y plus 4x minus 8 equals 0. I have never seen something like this before. This looks like something out of this world. Just calm down. Don't you panic. That's why we're here, alright? We're here to make sure this actually clicks and doesn't become a problem for you. So what I need to do here is I need to get this into the format of y is equal to mx plus c, where y is on its own. So let's first make sure that y is on its own in isolation on the left-hand side of the equal sign. So we're going to throw the 4x and the negative 8 over, making sure that we change the signs correctly. So we've got 2y plus 4x minus 8 is equal to 0. Right? Now, I need to now make it 2y equals. So I'm throwing this across and I'm throwing that across. Becomes minus 4x plus 8. Are we done? No, because I still have a coefficient of the y term. So, how do I get rid of this? Well, 2 times 1. I need to do the opposites. I need to divide this by 2. When I do to the one side, I must do to the other. If you ever get left with a fraction, don't stress. So I now cancel this. And these cancel out, so I'm now left with y is equal to, what's negative 4x divided by 2? Negative 2x. What's positive 8 divided by 2? Positive 4. And that's now my new equation. Now I've got the new equation for this line over here. So what do? I erase this. I don't want to see this anymore. Alright, and I fill in my new one, which is y is equal to negative 2x plus 4. And now we're well on our way in order to solve the questions that they have posed to us. And question number 1 is this. What is the gradient? What is the gradient of line Q? Now, because we have the equation in its pure form, I can just identify the gradient as being the coefficient, remember, the coefficient of the x term. What's the coefficient of the x term? Negative 2. So for question number 1, I can say m is equal to negative 2, or gradient is negative 2. That's my answer. Very well done. That's just through observations. I've done the hard work. If they ask me for the gradient of P, I want to say it is 1. There's no coefficients, that means it's just 1. Brilliant. Now the next question they've asked us, right, I haven't written them on the board because I need some space to work with, but the next question they've asked us is, what is the y-intercept? What is the y-intercept of line Q? And that can be done through observation as well. Because what do we know about line Q? We know that C represents the y-intercept. And C is positive 4. So the y-intercept, for number 2, the y-intercept of Q, as you can say, see, there it is. So y-intercept is going to be not just, we can't just write 4 because they want to know what the y-intercept is. We have to say the y-intercept, which is a point on the graph, alright, is going to be x is 0 and y is 4. Very important with that. If they ask you, where does it cut the axis of y? You could say 2, you could say 4, sorry. But you should always, they're talking about the y-intercept, they're talking about that point over here. And this point over here, or every point on a Cartesian plane, always has an x and a y point, coordinate should I say, x and y coordinate. So that's the answer to number 2. But it starts to get more interesting as they start to delve into questions like the next one. The next question states, does the point, I'm going to write this one out, these first 2 questions have been done. Somebody raised them, so I've got some more space. The question, and I want to write this down, is does, Q for question, does the point -4 and 12 lie on line Q? This line over here, line Q. Does the point -4, sorry, and 12 lie on the point Q? Many of my students really struggle with this because they're thinking to themselves, I don't know, because there are no points here. There are no points written down here with coordinates. I mean, how am I meant to know that? But the trick lies in this. This is what we can call the trick of the day. If we're looking to find a point on any line, that point needs to work with the equation for that line. So, they give you the point, -4 and 12. And our equation is y is equal to -2x plus 4. Remember, I can only do it if my equation is pure form. Now, in order for us to know if this point does lie on this graph, right? I'm saying this graph because an equation represents a straight line graph. Well, this equation does. If I substitute in my, we know this is the x value and this is the y value. If I substitute in my x value into this, so x over there, and I solve that y, because now y is what I'm left with, y is equal to 12, then it's all good. If I substitute in y as 12, alright, and I find x, I solve x to be -4. No, good. So I'm going to do both with it. So let's start with x. So y is equal to -2, close bracket, -4, plus 4. So y is equal to, what's -2 times -4? It's going to be positive 8, plus 4. So y is equal to 8 plus 4, which is 12. See how it worked? Brilliant. Now let's just do the other one, just to make sure that you understand that it can work either way. So here, I've now got, alright, I've got y, which is now going to substitute in for. We're not going to use y, we're solving for x. So we're going to say y is 12. So 12 is equal to -2x plus 4. Trying to solve for x, I bring the 4 over, so it becomes 12 minus 4 is equal to -2x. So 8 is equal to -2x. Divide both sides by -2. That becomes -4 is equal to, these cancel, to x. And that's the same thing. So it works. How incredible is that? Hey, it clicks, it all makes sense. So if we are here to find if a point lies on a given graph, it just needs to work when we substitute in either the x value and find the y, or we substitute in the y and we find the x to be true. Alright, now the last question I want to cover with you. The last question that I want to cover with you is this. What are the coordinates? What are the coordinates of the point of intersection? What are the points, what are the coordinates of the point of intersection of these two graphs? Where these two graphs meet, what are the coordinates? Now, this is a great question. This is a classic question in a straight line graph exam or a test. So, where these meet, right, we write down our two equations. We got y is equal to negative 2x plus 4, and we have y is equal to x minus 2. Now, if I'm going to find where they meet, I need to make this equal to that. And that's where they'll meet. So, I write negative 2x plus 4 is equal to x minus 2. I bring the x across, alright? I'm going to bring this x across, and I'm going to bring that positive 4 to the other side. So now I'm left with negative 2x, comes across, becomes a minus x, is equal to negative 2, goes across, becomes a minus 4. Now I can collect these, so I've got negative 3x is equal to negative 6. So, now, what do I know about this? Divide by negative 3. Divide by negative 3. Cancels, cancels. X is equal. What's a negative divided by a negative? Positive. Don't ever forget that. And 6 divided by 3 is 2. So now I know the value of x at that point over there is going to be 2. What is the y going to be? Well, because we're looking at this, we can tell that we can see it falls onto the x-axis, which means that y would be 0 there. But we take this x value and we substitute it into either of our equations. And that's how we find y. So, if we said x was 2, y is equal to 2 minus 2. What's 2 minus 2? 0. So now we know x is going to be, y is going to be 0 there. What about this one? Y is equal to negative 2 times 2. What does that give us? Negative 4. Plus 4, 0. So the coordinates of this point here are going to be x is 2, y is 0. How's that? What did I do? I made the right-hand sides of my equations equal to one another to solve for x. Once I found the x value of this point of intersection, I substituted that back into either one of my equations. And I did it to both just to show you that it would be the same answer. No need to do it, but maybe you could do that in a test to make sure that you don't make that silly mistake. I know it's starting to make sense to you right now. And that's why you should be subscribing to Qlicked. You're here for a reason, you're here to learn. And we're here to give you as much help as possible. So drop us a comment below, let me know what you thought of this video, and tell me what the answer to this homework question is. I've got y is equal to 2x plus 6, so I was taking it down from a board, 2x plus 6, and that is equation number 1. Equation number 2 is going to be y is equal to 2x minus 3. Those are my two graphs. What do I want you to do? Well, I want you to do what I just did right there at the end. I want to know what, alright, are the coordinates of the point of intersection. So I want you to find the point of intersection. Where do these two graphs meet? And which two, or what are the coordinates of the point at which these two meet? And that's it. It's been great to see you again. Have a fabulous evening, and we'll see you next time. Cheers.